Good morning to one and all. Today we are going to deal with the things of measuring instruments here right now. Yeah, these are the contents we have to cover in this particular session. Classification of instruments and what are the essential requirements of these indicating instruments. Moving iron type meters, moving coil type meters, and finally Wheatstone bridge. Yeah, all these are some basic units here. We all know that for the part of length, meter is the basic unit, mass, kilogram, time, second, electric current, amperes, voltage, volts, power is obviously watts, energy, joules, intensity, it's a candela. All these are some basic requirements. FPS stands for foot, pound, second. CGS stands for centimeter, gram, second. MKS, meter, kilogram, second. All these are some standard fixed things here. We frequently use this kilo, 10 cube, and also mega also there, 10 power 6 mega. Whereas in terms of milli, we can use some small letter m. It's 10 to the power of minus 3. Micro in the sense 10 to the power of minus 6. It's indicated with mu. And what's that basically a measuring instrument here is? It's just a device to measure physical quantity. And it is used for comparing the unknown quantity with the unit of measurement or standard quantity. It's called measuring instrument. And what are the different essential requirements of indicating instruments here is you have to follow all these three types of torques. Don't forget these three torques here. It plays a crucial role. The first and foremost thing here is deflecting torque. Second one, controlling torque. And the third one, damping torque. Don't forget these three things here. Controlling torque, damping torque, deflecting torque. In order, let it be we are having some pointer like this. In order to move this pointer, there is a torque here. The torque may be called it as deflecting torque. In order to stop at some particular equilibrium position, there is some opposition torque will be there that may be with the help of controlling torque. When these two torques are equal, collide with each other, there is some oscillations can be happen. At the time, we have to nullify those oscillations with the help of some torque. That one may be called it as damping torque. Yeah, deflecting torque is produced by making with the help of magnetic effect, heating effect, chemical, different principles. In our syllabus wise, we are having some PMMC instruments now. In that, we may use some motor principle in order to deflect these things. Controlling torque is provided with the help of some springs or else with the help of some gravity control. Two types of controlling torque will be produced. Yeah. In terms of this spring here, we can try to remember that controlling torque is directly proportional to angle of deflection theta. Yeah, this one is the thing. I can use some spring above the pointer like this, and below the thing also we can use some spring. When the pointer deflects, the spring will tighten out. When the after the reading has been done, again it moves towards the part of original position. At the time, the springs will lose that elasticity nature. This one can use it with the help of some spring control method, or else we can use some gravity control method also there. Yeah, this one is a gravity control. Just for the part of this pointer, just observe. For the part of this pointer here, they can use some control weight here. Perpendicular to the part of control weight, we can have some balancing weight is also there. This one is the balancing weight. This one is controlling weight. And we can connect it to the pointer. When this pointer moves, same thing, this one also moves with the help of perpendicular structure like this. Yeah. And we can have some balance weight and control weight. Moves towards the part of like this perpendicularly towards the part of control weight and balance weight. We can have this controlling torque is directly related to, right now for this one, it's a sine theta. Whereas previously for this spring, controlling torque is directly related to only angle of deflection. Whereas this one, it's a sine angle. Damping torque, in order to nullify those oscillations, we can have some different types of dampings here. The first one, yeah, we are having some air friction damping, fluid friction damping, eddy current damping. First of all, air friction damping is nothing but we can have some air chamber here, and we can connect it one piston like this. And when the pointer moves, this piston will have some opposition nature like this. And with the help of this air chamber, it nullifies those oscillations, deflections. With the help of one chamber, that chamber may be called it as air chamber. If I'd like to fill it some oil like this, that may be called it as fluid friction damping. Our main intention here is I'd like to nullify oscillations. Same thing. In order to that air chamber, I can fill it out with the help of some oil. Due to the viscosity nature of the soil, when the spindle presses here, the viscosity nature will oppose that particular oscillations will damp out there. This one may be called it as fluid friction damping. Same thing in a similar fashion, we would like to go for the part of eddy current damping. What's that eddy current damping is nothing but they can choose some disc like this, and they can choose one permanent magnet. Permanent magnet is nothing but North Pole and South Pole now. Flux lines travels from north to south like this. When the spindle rotates, these flux lines will carry some current, and those currents are in opposition to the part of this particular spindle disc nature, and it can damp out those oscillations with the help of this eddy currents. With the help of this eddy currents, the direction of rotation of this disc will nullify those oscillations with the help of eddy currents. When a conductor moves in a magnetic field, we already know an EMF is induced in it now. If it is a closed path, it can convert the things into current. Those currents may be called it as eddy currents. This current interacts with the magnetic field to produce an electromagnetic torque that opposes the motion. This torque is maybe called it as damping torque. Yeah, these are the essential requirements. Deflecting torque is obviously we can use some motor principle. Controlling torque, spring or gravity. Damping torque, we may use air friction damping, fluid friction damping, and eddy current damping. Coming to the part of first instrument here, permanent magnet moving coil instrument, PMMC. And you have to remember what are the three essential requirements: deflecting, controlling, damping. That's enough. Yeah. For this, we have to draw this diagram like this one. I would like to remember the name permanent magnet. We have to choose some north and south pole. This one is a permanent magnet. And this shape may be called as it's a coil. This coil will move. And I can connect it one pointer for this one. This one is a pointer. And I can choose some balance weight, and this one is a control weight. This one is a pivot and jewel bearing. There is no sharp edge. It has to make it one sharp edges like this. And inside the part we can have some core. Yeah, this one is a coil and fur. Yeah, when current passes across this particular coil, it is placed in a magnetic field. It experiences some sort of torque. That it is nothing but we already know F equal to Bell sin theta. Deflecting torque is equal to force into perpendicular distance. Whenever a current carrying coil, this one is a current carrying coil I of length L is placed in a magnetic field B, it experiences some sort of force. And the turning or twisting amount of this force will result in the part of deflecting torque. Then the pointer will move. When the pointer moves, that may be with the help of a star deflecting torque. In order to stop at some particular point, I may use some springs, or else I can use some balance weight for the part of gravity control. In this one, I can use one spring here right now, and to the part of down also we can use some other spring. With the help of those two things, we can have some spring control. And we also have some damping now. We can use some eddy current damp. Remember, all these three you have to write. And you have to remember the principle here. This one is a crucial line. It operates on the principle that torque is exerted on the moving coil placed in a magnetic field. That it is motor principle. Remember, we can use some motor principle. For the part of which thing? PMMC. All these are we can use some moving coil now. It's on a copper wire. And for this one, magnet system, we can use some Alcon Max or Alkino material. Controlling torque is produced due to the part of which thing here we can use some spring control. For the part of spring control, controlling torque is directly related to only angle of deflection theta. Damping torque is provided with the help of some eddy current damping. Remember, all those three torques plays a crucial role: eddy current, damping. These are the three lines you have to write. All these we can have some pointer and scale for the part of measurement. We can have some torque equation now, that it is deflecting torque is equal to NBL into DL is length, and we can have some current is nothing but through the coil I. Just remember, for the part of deflecting torque, we have to remember one formula, BI and B now. V stands for flux density, I stands for current, N stands for number of turns of the coil, A stands for area. Yeah, the deflecting torque is directly related to current. And the deflecting torque and controlling torque are equal. That one is the final deflection position or equilibrium position. This line also you have done. At that time only we can observe exact reading. Coming to the part of advantages, the scale of the PMMC is correctly divided. The power consumption is less. High accuracy because of its high torque to weight ratio. The PMMC instruments are shelf shielding magnet, which is useful for the aerospace applications, aeroplanes. Disadvantage point of view, it can measure only DC quantities. It can't measure AC. That's the only disadvantage. Cost wise also it's somewhat higher compared to another instruments, that it is moving iron instruments. These are the things you have to write: circuit diagram, and what are the three tasks, and what are the advantages and disadvantages. The next one here, moving iron instruments. In this moving iron instruments, the name itself indicates the part. For the part of iron material, we have some two natures there. One thing is attraction, another one is repulsion. Those are two types: moving iron attraction type, moving iron repulsion type. The first thing we have to choose here is this one is the thing. We can have some pointer, same balance weight. We can have some iron material. This circular nature maybe call it as it's an moving iron material connected to pointer. We can have some control weight, and we can have some chamber, air friction chamber. Three times we have to cover it now. For the part of deflecting torque only, we can have some principle here. To the part of iron material I have chosen here now. When current passes across this particular coil, we can produce some magnetic field, that it is north pole and south pole like this. Then this iron piece will attract it towards the part of this magnetic field. Then the pointer will deflect. Due to the attraction nature, deflecting torque will occur. And the balance weight and control weight will use it for the part of controlling that pointer at some particular equilibrium position. And if there is any oscillations, we have to nullify with the help of some air jump. That's it. Only 3 points. It works on the principle of which thing here? Only one thing. It works on the principle that iron is placed in close to the part of magnet and it attracts towards like this. This attractional force is based on the magnetic field strength. That's it. Construction is everything here. Same. I had to use some sheet of soft iron piece. Magnetic field. That's it. Moving iron is mainly classified into attraction type and repulsion type. This one is attraction type. We can have some coil now. Same. We can create some magnetic field and this iron piece attracted and it deflects its pointer. Then in order to stop some particular position or equilibrium position, the deflecting torque is equal to controlling torque. That controlling torque can provide here as with the help of some gravity control. And this air friction damping is nothing but damping torque. And we can have some attraction principle is for the part of deflect. That's it. 3 points. Repulsion type, same principles, but you have to remember two pieces now: moving iron, fixed iron. For the part of moving iron only, you have to connect this spindle. This one. Obviously, we can create some north pole, south pole like this now. Same moving and fixed irons, we can create same poles, that it is north, north, south, south. then it can repel each other. Then the deflecting pointer will move. Same principle that it is due to the repulsion nature, the pointer will move. And we can observe one thing here, deflecting torque. If the pointer moves, and obviously we can use some springs for the part of spring control, we can use some air friction or fluid friction for the part of damping torque. That's it. These are the three things. In this, the pure nature here is repulsion type instrument. And we have to remember for the part of moving iron instruments, deflecting torque is directly proportional to I square. You have to write deflection torque is directly related to square of the current. Don't forget that line. Whereas previous one only current, PMMC. These are the different advantages of moving iron instruments here. We can use it universally for both AC and DC supply. Don't forget that line. Whereas PMMC is only used for DC. It's a less friction error, cheapness, and robustness. But we are having some errors here, disadvantage point of view. It's not accurate, and we can have some waveform error also. These are the different disadvantages of moving iron instruments. Remember this comparison table here right now. Basis of comparison wise, moving iron instrument, the soft iron piece we have to use it. Whereas in moving coil, we can use it some coil now. That conductor coil is used for the measuring of current and voltage. The working principle of moving iron is only magnetism, attraction or repulsion. Attraction or else repulsion. Whereas it's similar to the working principle of only motor, that it is F equal to Bell sin theta. Accuracy wise, it's a less accurate moving iron, it's a more accurate. And it can use for both AC and DC supply, MI instruments. Whereas MC instruments are only used for DC measurement. Scale wise, moving iron instruments is a non-uniform. Y means it's a square of the current. Square in the sense, let it be, I can choose some 2, next option 4, next option 16. It's a non-uniform. Whereas this one, 1, 2 like this. Damping wise, air friction or fluid friction they can follow here. Whereas this one only can use eddy current damp. Power consumption is high for moving iron. Whereas this one low. Controlling torque is due to the gravity or spring. This one is obviously spring. The deflecting torque is square of the current. Whereas this one is only current, Bina. Whereas this one is square of the current. Hysteresis loss doesn't occur, whereas it can occur here. We can use it for the part of current measurement, ammeter, voltage measurement, voltmeter, this one wattmeter. Same things. Yeah, voltmeter, ammeter, galvanometer, and ohm meter for the resistance. These are the different classification of moving iron and moving coil. Don't forget these two things. Plays a crucial role. Coming to the part of next thing here, Wheatstone bridge. Wheatstone bridge is nothing but it can use it for the part of resistance bridge, or else it can calculate the unknown resistance. Yeah, by balancing two legs of the bridge. One leg includes the component of unknown resistance. The Wheatstone bridge consists of two known resistance, one unknown resistance, and one variable resistance. Remember, two known resistance, one unknown resistance, another one variable resistance. This bridge is very reliable for the calculation of accurate measurements. Observe this one is a circuit diagram for Wheatstone bridge. We can have some four legs now, P, Q, R, S. This one is a variable resistance. This one is the unknown resistance. These two are known resistance. That's it. When the bridge is balanced, remember, when the bridge is balanced, the deflection galvanometer reads 0. The bridge is unbalanced, there is some current value will occur here. Some value has to be shown here. That's the only thing. They write something like this. Working principle. Don't forget the working principle. Wheatstone bridge works on the principle of which thing? Null deflection. That it is the ratio of the resistance are equal. No current flows through the circuit. That one is the principle. Under normal conditions, the bridge is an unbalanced condition. At the time, current flows through the galvanometer. The bridge is said to be balanced when no current flows through the galvanometer. This condition can be achieved by adjusting the known resistance and variable resistance. That's the only thing that it is. With the help of some derivation, I can clarify those things here. Observe same diagram. The following condition exists when the galvanometer becomes 0. If the value of this galvanometer is 0, at that time these two are connected in series and these two are connected in series. That it is I1 current is equal to I3, I2 current is equal to I4. Observe this one. And I1P is equal to I2R. I1P is equal to I2R potential. That it is I1 is equal to I3, or else we can write voltage divided by these two resistors are connected in series now, P plus Q. This one. Same. I2 and I4 are equal when the bridge is imbalanced. E divided by R plus S. Here E is the EMF of the battery. And we can substitute I1 and I2 in equation number 2. These two values I would like to substitute in equation number 1. This one. We can have some equation like this. By simplifying all those things, we can find out the value here, that it is unknown resistance R is equal to P by Q into S. Or else we can simply write this one is nothing but P by Q, that it is P divided by Q is equal to R by S when the bridge is in balance condition. This one, ratio of these arms is equal to ratio of this particular arms. And we have some applications point of view. It's a precise measurement for the part of low resistance only there. It can use it an operational amplifier for the measurement of physical parameters, temperature, light, and strength. Quantities such as impedance, inductance, and capacitance can be measured using the principle of Wheatstone bridge. Limitations wise, it can measure only low resistance. For a high resistance measure, it is not suitable. The other drawback is resistance change due to the current's heating effect. These are different drawbacks of Wheatstone bridge. Thank you. Thank you, one and all.